Today we're going to continue our study of histology by looking at epithelium or epithelial tissue and some characteristics that make it different from connective, muscle, and nervous tissue. The advantage of using a flipped lecture like this is that you can stop the presentation to catch up or replay things that would help clarify what I've said. Today we're going to look at epithelium tissue in terms of its function, how you classify the different types, examples in the body of the different types, and terms used to describe epithelial tissue. In terms of function, epithelium usually serves one of the four things that you see on the screen. It works as protection, to keep things that should be outside out, to keep things in that should be in. It works where we have absorption of oxygen, food molecules, water molecules. So we find that function occurring in the digestive system. Filtration is another function that epithelium has, and a good example is in the kidney, where things like water, salt, urea are filtered and allowed to go out, while other things like red blood cells stay in the blood and inside the body. And then secretion. So your body secretes sweat, oil, digestive enzymes, endocrine substances or hormones, and those are also produced by epithelium. Now we'll go on to talking about classification. Basically, classification is done based on two characteristics. How many layers does something have, and what are the shape of those cells? In terms of layers, we refer to epithelium as either simple or stratified. Simple means that there's a single one layer of cells. Stratified means that two or more layers of epithelium make up the tissue that we're looking at. The other characteristic that we use is the shape of the outer layer. We have three basic shapes. Columnar means that it's shaped kind of like a shoebox tipped on its end. So if I look here, again, it looks like a little shoebox or a rectangle. Cuboidal cells look like sugar cubes or dice, so they're square. And the last kind of cells are squamous. Squamous means flat. So if we look at them from the side, they're much longer than they are tall. If we look at them from the top, they're going to look like floor tiles or fried eggs that are touching each other. As we continue, let's look at some examples of these kinds of tissue and where you'd find them in the body. So simple squamous means you have one layer of flat cells. This allows for the quick diffusion of things between the two sides of the tissue. Examples of that would be the alveoli in your lungs and capillaries that are part of your cardiovascular system. Simple cuboidal cells are typical of glands. So you have a bunch of these boxes set next to each other with an opening in the middle, such as what we saw up here. So the cells make kind of a circle, but they're a little bit square-shaped, and then they excrete the hormone that they make into this opening. The third simple kind of tissue we could have would be simple columnar. One layer of rectangular-shaped cells, and that's typical of your digestive system. Stomach, small intestines, large intestines. Stratified squamous means that you have many layers of flat cells. Near the bottom, they're going to look a little bit more cuboidal, but as we learn layer, we always identify epithelium by the shape and characteristics of the top layer. So again, stratified squamous means that you have more than one layer of basically flat cells. These are designed to take abuse And so your skin is a really good example. A couple layers of your skin can wear off. You don't start bleeding because there's other layers below it. Stratified cuboidal and stratified columnar are very rare, and so I won't hold you responsible for knowing exact examples of those, although the ducts of some of the larger body glands would be made of those types of tissue. The last kind of tissue is transitional, and that means that the cells can kind of change location and shape depending on the force being applied. And that is typical of your bladder. So it stretches to get bigger as more urine collects within it. The last thing that we want to look at is some terminology. And as you can see, there's a lot of terminology. The first word we'll talk about is apical. Apical means the free edge. So when I'm identifying epithelium, I'm going to look at the top layer where there's no more cells on top. Thus, this is the apical edge or free edge. The basement membrane is a layer that is between the epithelium on the top and connective tissue on the bottom. So it's this thin layer that is under the epithelial tissue. Goblet cells are a special kind of cell that is between the other epithelial cells. And what goblet cells do, you can see them in this picture. They kind of will look like a hollow or empty space between the other cells because they don't absorb the stain the same way. But the function of goblet cells is to secrete mucus. That mucus would line like your stomach so that the stomach acid doesn't erode or hurt the epithelial tissue that your stomach is lined with. The lumen is another term that applies to some epithelial tissue. And basically, if the tissue makes a circle, the hollow space in the middle of that would be the lumen. So its definition is the space within an organ. An artery would be an example, your intestines, the inside of your trachea. So this picture shows you the lumen on the inside. It shows you villi, which we'll get to later, little folds. And if you imagine that the rest of this diagram was completed, you'd have this hollow space in the middle. The hollow space is the lumen. The last few words we have here are villi. And villi are folds in tissue to increase its surface area. So again, if we look at this picture, you can see the little folds here in the cross-section of the intestine. That gives the intestine more area to absorb nutrition. And here's an example again. You can see all these folds would give you more surface area than if this were just flat. Microvilli are simply villi on villi, or folds on folds, or basically folds in one cell. So if I look back up here to the top, you can see these tiny little folds on this top apical edge. Those would be microvilli. The last word that we have is brush border. And basically, brush border refers to any surface covered with villi or cilia. Most of this information is a summary of what you'd find in your book on pages 87 to 92. So you might consult that if there were parts of this that you'd like more clarity about. That is it. Thank you for listening.